start our class today with a quiz. Right. So as usual, for those who can score in this quiz, so you can get a bonus mark, which will be given later to your test too, or maybe some other marks will be going to your final exam. All right. So you can refer any notes. So basically, the quiz will be on interrupt 21H. Okay. So before we're going to continue with another section, okay, later with the new chapter on the keyboard and also mouse programming. Okay, so let me open up the quiz. Okay, there you go. Right, so you can go there, join myquiz.com, and then enter the code 677411. Right, so I believe almost all of you are here. Right, so you can start joining the group, and I'm going to start it very soon. Okay, we got first participant there, right? Okay, you guys ready? So I'm gonna count from 10. Right, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Doktor kejap. Sekejap internet. Sekejap internet.
Okay, I'm going to start it. I'll give you a couple of seconds. Okay. You're going to start from 3, 2, and 1. Right, enjoy the quiz. Okay, I'm going to stop the quiz now. I need to get a couple of you still answering. I'm going to stop it now because I'm doing so long for you to answer this quiz. Okay. Okay, good. So 3 of you got 100% correct. Okay, and then the rest 77%. Okay, so for another 3 of you. After that, we both got so below 70%. Okay. All right. So so the most mark will be given, of course, to the top scorer, and then the others will also worry. Okay. As long as you can answer that at least 50% of the answer is correct. Okay. Congrats for those the top leaderboard. Okay. Right. Before I'm going to start with the lecture, do you have any questions so far regarding your test 2? So basically, the test 2 will be similar to the test 1, right? Where all of them will be subjective, right? So you're gonna have the same amount of question, and in test 1, the answering time will be also 1 hour. Okay. And then just do the practice as much as possible using the questions that I give you, right? Okay. So if there is no question, then we're going to start with a new chapter, which is about the keyboard and also mouse programming. I'm going to share shortly the notes with you. Give me 1 minute. Okay, there you go. So you can download it on the WhatsApp. All right. Okay, in this new chapter, you're going to look into another interrupt actually for you to check the keyboard, right, and also the mouse, okay, which is interrupt 16H and also interrupt 33H. Okay, so interrupt 16H is controlling the keyboard, okay, and also interrupt 33 is controlling the mouse. Okay, so basically this is the objective in this chapter. Okay, so our original keyboard, which is the IBM keyboard, has had 83 keys. Okay, so it is grouped into three groupings, which are the standard, okay, typewriter keys, okay, 10 function keys from F1 to F10, okay, and then 15 keypad. Okay, and then later, so we're gonna have 101, right? Key enhanced keyboards. Okay, and now this is what we are using right now. Okay, so for each key on your keyboard, it is actually associated with a scan code, right? So the scan code, actually you can look, all right, in the textbook. So it is in page 162 and 163. Okay, so you have the table there, all right? You have the table giving that you have the codes, all right? So let's say you have the hex number and also what is the related key, okay, with that hex number. Okay, so the same scan code is used for a given lowercase letter and its capital. So for example, capital R and also lower R is also using the same scan code. Okay, and also for all keys with dual label. Okay, for example, uh, number 3 and H. Okay, 3 and H, the in your keyboard, so you have 3 and also H. So meaning that when you shift it, so it becomes H, and if you don't shift it, it becomes 3. So that's the dual key. All right, so that also have similar scan code. Okay, so the keyboard shift status by distinguishes the key. Okay, as I said, if you shift, then it will become a symbol. Okay, shift, it becomes a number. Okay, so some interrupt 16 function calls provide the status bytes in register AL. For keyboard motherboard interaction, IBM has provided interrupt 16. Okay, so when a key is pressed, the OS, the operating system, stores the scan code in memory location called a keyboard buffer. Okay, for example, when we press a key in our keyboard, okay, and then it will be sent directly to the keyboard buffer, which is located in the BIOS data area. So this one is actually inside the CPU, right? Because the keyboard needs to function with the CPU, right? If it is going to the RAM, okay, so how come it will work during the BIOS? Okay, so that's why the keyboard must, the keyboard buffer should be inside the CPU. So inside the CPU, there is a memory location, okay, called that the keyboard buffer. Okay, it is located in the BIOS data area. Okay, so we have a couple of bits. Okay, Okay, so over there we have table 5.54. All right. So it gives you the status of the byte. Okay, so let's say you have a 8-bit register. Okay, so whenever there is a shift press, okay, if there is a shift press, they will change. Okay, according to the whatever is shifted. Okay, so for example, there, okay, you have the shift button, right? And you have right and left shift. So that's related to bit 0 and 1. And we have also control, alternate button, scroll lock, num lock, okay? And then also caps lock and insert. All of that, okay, is actually the shift status byte, okay? So that distinguish the key, right? So whenever you press that and you press with another key on the keyboard, okay, so that will change the keyboard status. Okay, so for a program to run tasks continuously while checking for a key press, it requires use of integer 16. Sorry, interrupt 16. A BIOS interrupt used exclusively for the keyboard. Okay, for example, if you want to check a key press, okay, we use interrupt 16 function AH equals to 01. Okay, so so you move 01 to AH, so it should be 01 there, and then get key press, okay, interrupt 16. Okay, so you check at the flag. Okay, if the flag is 0, okay, the 0 flag. So if the status is 0, so your 0 flag will be 0. So it actually activates the 0 flag. Okay, your 0 flag will always stay as 1 when there is no key press on the keyboard. Okay, so when you are not doing anything, okay, once you function AH, right, equals to 01, so if you don't press it, then your 0 flag becomes 1, meaning that there is 0 status. But if you press a key, then you no longer have a 0 flag. Okay, so your 0 flag becomes 0. Okay, so that means the keyboard is pressed. Okay, so actually this function does not wait for the user to press a key. Okay, it is just to check if there is a key press. Okay, if a character is available, it returns the scan code in AH, okay, and the ASCII code in register AL. Okay, for example, over here, we have a program that sends the ASCII, okay, the bell character, okay, 07, okay, to the screen continuously. Okay, so we have the program here. So you want to show you the message that to stop the bell sound, press any key. Okay. All right. So it will stop the bell if any key is pressed. Okay. So meaning that right now the bell sound might be heard. Right. So you need to press any key to stop the bell. Okay. So first of all, so you need to change your AX. So you put data into the AX, okay, and AX move to DS, and you put 09 to the AH, okay, and then you use interrupt 21. So you remember that you want to output when you use the interrupt 21, you want to output the string, okay. you want to output the string. Okay, so meaning that this string will be shown on the screen. To stop the bell sound, press any key. Okay, and then this will function after that. So you move to AH, you set to 02, and then 07 set to DL. Okay, interrupt 21. Okay, so with that you input the character or the string to the uh, to the CPU, all right, to the CPU. So again, you use interrupt 21, right? And then, okay, now you want to check the key press, you change the AH, okay, to 01, okay, and then use interrupt 16, okay. So now you check whether the key is pressed or not. Okay, so if there is a key is pressed, okay, it will it will pass, the jump 0. Okay, it pass jump 0, mean that it will go straight to move AH for C. Okay, but if there is no key press, the statement is repeated again and again until key is pressed. Okay, from here, so you go jump to here, okay, again and again until key is pressed. Okay, so when you set AH01, okay, just want to know whether a key is pressed or not. Okay, but if you want to know what key, okay, which key is pressed, so you need to set that AH becomes 0, okay, and then use interrupt 16. Okay, this is used immediately after you set AH equals to 01. Okay, so AH0, okay, doesn't return until a key is pressed. Okay, AH1, okay, comes back whether not key has been pressed. Okay, so mean that AH will wait. Okay, we wait what key is going to be pressed. Okay, AH0 going to wait, but for AH1, okay, it won't wait. It actually gives you the result whether the key is pressed or not pressed. Okay, but for the AH0, it needs a key to be pressed, and then you need to give you the information what key is pressed. Okay, so the AL, so when AH is 0, so AL will contain the ASCII character of the press key. Okay, and then the scan key will be located in AH. Okay, so for character of F1 to F10 on your keyboard, okay, there is no ASCII code. Okay, the scan code is in AH and L goes to 0. Okay, so if AL is 0, okay, a special function key was pressed. Okay, so meaning that it will, so you see the difference here. Okay, whenever a key, so let's say you type a character A, B, C until Z, right? So that will be moved to AL. But when AL is 0, meaning that a special function key is pressed, meaning that your F1 to F10 is pressed during that time. Okay, so that's how the CPU distinguish, right? Which key on the keyboard that you press. Okay, so all right, so here is the continuation of the code before to know which key that you press to stop the keyboard. To stop the bell. Okay, so you need to stop the bell using key Q, right? Using key Q. Okay, so the first few lines, okay, are similar. Okay, these are similar, right? And also these are similar. Okay, it changed only after here. Okay, after that. Okay, so that you need to add more instructions. Okay, so okay, you see over here. So first it is written as AH01 and then next AH0. So it needs to wait. Okay, what key is going to be pressed? Okay. All right. So if it is Q, so you will check. If Q is pressed, then it will compare. AL will compare. If compare is 1, okay, jump equal, okay, mean that equal, so compare is 1, then it will exit. It won't go to, sorry, it will go to exit. Okay, it will go to exit, meaning that the correct key is already pressed, meaning that Q is already pressed. But if it is not correct, okay, if it is not correct, it will compare again whether the key is smaller q. Okay, so first one you check whether the key is capital Q, and then next, okay, if compare is equals to 1, mean that it is already achieved. So go to the exit. So jump exit. Also check again if compare equals to small q. If it is satisfied, then again you write the same statement, jump exit. Okay, you will go to exit. Okay. Okay, but if that is not satisfied, it will go back to the again. Okay, it will show you the character, the message again. To send that, you need to send out a message of the key of Q in order for you to stop the sounding bell. Okay, so it will wait until Q is pressed, then only this program can be exited. Right? Okay. Right. So that is related with the keyboard programming. Okay. So you check whether key is pressed or not pressed, and what type of key is pressed, right, on the keyboard. Okay, so that's the function of interrupt 16. Okay, so you have another function of interrupt 16, which is AH equals to 10. Okay, so what it does, okay, here it read a character. So it is similar as AH0, except it also accepts the original or additional keys on the IBM extended keyboard. Okay, and you also have set as AH equals to 11 to find if a character is available. Okay, so it is similar like AH1, right? Except it also accepts the additional keys on the IBM extended keyboard. Okay, so that is about the keyboard programming. Okay, so we also have the mouse programming. Okay, so that is used with interrupt 33. Okay. Okay, so the original IBM PC and DOS did not provide the support for mouse. Okay, so interrupt 33 is not part of BIOS or DOS. Okay, interrupt 33 is part of the mouse driver software installed when the PC is booted. Okay, so as you've seen that During the BIOS, your mouse is not working, right? So your mouse is not working. So you can but for modern for modern computer, so the mouse is already can be operated, okay, within the BIOS. Okay, so that's because it is actually the Interrupt 33 is already designed, okay, within the BIOS. Okay, so that's why it can work as of now. Okay, so the first task of any Interrupt 33 program should be to verify the presence of a mouse and a number of buttons it supports. Okay, so for the old mouse, use like 3 buttons. Okay, but for nowadays, so you have 2 buttons and a scroll. Okay, so to verify the presence of a mouse and the number of buttons it supports, we use the function of AS0. Okay, with the Interrupt 33. Okay, so if return from the Interrupt 33, AX is 0, so no mouse is supported. But if AX equals to FFFF, the mouse is supported and the number of mouse buttons will be contained in the register BX. So although most mice have 2 buttons, right and left, okay, there are some with middle buttons as well. Okay, so the old mouse has got a middle button. Okay, so as usual, so we have moved A at 0. So we want to know whether the mouse is present or not. So we type interrupt 33, okay, and then compare. Okay, compare, so meaning that you want to check the AX content. Okay, if the AX content is not 0, okay, then you will have the mouse presence. Okay, so over there, so jump equal mean that is okay if no mouse is presented, so it will go to exit. But if mouse is presented, it will pass the jump. Okay, so the button is saved, okay, into the BX. Okay, okay, so for, as you remember, in interrupt 21 and interrupt 10, register AH is used to select functions, okay, but not in the case of interrupt 33. Okay, so you remember that AH09, AH0A, and so on used in interrupt 21. So for you to do the different function, but in interrupt 33, it's not like that. Okay, so AL is used to select various function, and AH is set to 0. So AH is set to 0 because it is dedicated to the mouse. Okay, to mention the presence of the mouse. Okay, so that's why it need to have that statements remain. Okay, move AX 0. Okay, so if you want to make sure your mouse is working, right? So without the initialization of move AX 0 with interrupted 3, then your mouse will not function. Okay, so there's a simple note, small note over there to mean that as usual, so for any interrupt, although I mentioned 33, 31, you still need to put the H at the back, okay, to ensure that the compiler will able to recognize, okay, that you type that is a hex number. Okay, Now, once you initialize the mouse, so you know that the mouse has got cursor, right? So as you can see here on the screen, so it got cursor. So of course, we are interested in know where the mouse is pointing. Okay. Okay, in graphics mode, it is an arrow. Okay. In text mode, it is a flash. So as you type, okay, as you type, right, in the text mode, so you have that typing cursor, right? And then in graphic modes like this, so you have the arrow, or like what I use here, you have the marker, right? Okay, as the mouse is moved, the mouse cursor is moved. Okay, while the movement of the mouse is measured in inches or centimeters, movement of the mouse cursor on the screen is measured in units called Mickey. All right. So you have the Mickey Mouse over here. Okay. Mickey is actually indicates mouse sensitivity, right? So you have mouse and the Mickey. So Mickey is actually measuring the mouse sensitivity. Okay. If you know that to measure the sensitivity of the mouse, let's say you move only a little bit, okay, maybe movement is very large, right? If sometimes you like it to be very large, but some of the people like it to be moving slowly, right? So you change that Mickey units, right, to change the mouse sensitivity. Okay, so a mouse that can move the cursor 200 units for every inch of mouse movement has a sensitivity of 200 Mickeys. Okay, so 1 Mickey is considered for 1 unit of inch. Okay, so mean that 1 Mickey represents 1 over 2 inch on a string. Okay, so for every inch, okay, 1 inch, for example here, so let's say this is 1 inch. Okay, so you basically you have 200 units of mouse movement over here, mouse sensitivity. So there are so many points, all right, up to 200 for every inch. Okay, so 1 Mickey is 1 over that 200 of the inch. Okay, some mice has a sensitivity of 400 Mickeys in contrast to the commonly used 200 Mickeys. Okay, so this is usually used by the graphic designer, right? So to ensure, let's say, want to make it very precise, okay, and then at which part of that, so you need to use a higher sensitivity mouse. Okay, so okay, you know, you learn about the AX0, and then now you have AX1. Okay, so AX1 is used to display the mouse cursor, right? So you type move AX1 interrupt 33. Okay, so if the mode video mode is graphics, the mouse arrow is visible. If the video mode is in text, the rectangular block representing the mouse cursor becomes visible. Okay. So right. Okay. So you know, right? So I don't have the okay, because this is in this slide I don't have actually I want to show you the rectangular block. So I hope you know that the rectangular block is the one that for example you type in the Microsoft Word, right? So that's the rectangular block. Okay, so like this one. Okay, like this. So it is in the, as you can see, it is in the Okay, so this one is in the text mode, right? So you have different cursor, right? Okay, and compared to previous one, you have the arrow, so which is in the video mode. Okay. Okay, so the color of mouse block is the opposite of the background color in order to be visible. Okay. So if the background is white, then the cursor needs to be black, to be visible. But if the background is white, the cursor needs to be black in order to be visible. Okay, so to hide the mouse cursor after making it visible, okay, execute option AX02. Okay, also using 53. So when the video mode is set to text mode, the mouse will automatically adopt the same resolution, okay, of 640 times 200 for its horizontal or vertical coordinates. Okay, so when a program gets the mouse cursor position, values are provided in pixels and must be divided by 8. Okay, so this is actually depends on the resolution of your monitor, right? So the mouse will adopt the same resolution as that. Okay, so it has 640 for the horizontal coordinate and 200 for the vertical coordinate. Okay. Okay, so to get a position in terms of character 0 to 79, it needs to be divided by 8. So because 640 divided by 8, you obtain 80, right? So it will show you up to 80 locations. And then if 200, okay, divided with 8, so that also will give you in terms of 25, okay, 25 times 8, so you get 200, right? So that's why you get the position, okay, the position based on the cursor location on the monitor. Okay, so in the graphic modes, the resolution is 640 times 200, okay, can also be 640 times 350, or it can be 640 times 480. Okay, so you can see that when the mouse resolution actually follows the video resolution. Okay, and then the characters per screen, okay, will change, okay, as you need to divide all of this number by 8, okay, and then you will obtain the characters per screen. Okay, and then the video mode, okay, change when you change the AL. Okay, your AL change, okay, then your video resolution and also mouse resolution also change. Okay, so you have that. Okay, option AX0, okay, you know that presence of the mouse. AX1, so where you determine the cursor, all right, of the mouse. Okay, 02, okay, you want to make the cursor to invisible, all right, and then AX03, you want to get the current position of the mouse. Okay. Okay, so X and Y coordinates, okay, we put that in register of CX and DX. Okay, so BX contains the button status, okay. 1 is if down and 0 if up. Okay, so you see that you click the mouse. Okay, you click the mouse, right? So if the mouse button you click, okay, down, then BX 1, and then if it is up, it will be 0. Okay. Also, you have the D0, D1, D2 over there. So that's considered for left button, right button, and also the center button. The cursor position is given in pixels. Okay. As I mentioned before, you need to divide by 8. Okay. In order to know the horizontal and vertical location, okay, of the mouse. Okay, and then you also have the option AX04. Okay, so 03 is to know the location of the cursor, right? But okay, you want to program, so that cursor will be at another location. Okay. Okay, so of course it still can be similar resolution. Okay. So the coordinate 00 is the upper left corner of the screen. Okay, so upper left corner of the screen over there is 00, and over here will be 080 and 24, right? Sorry, 079 and 24 over here. Okay, and then next you have AS05 is used to get the information about the specific button pressed since the last call to this function. Okay. So for example, you have AS05, okay, so be at 0 for 1 for right button, 2 for the center button. So for upon return, so AX will give you the status of button, okay, right? Because you type AX05, then you should get the button status, right? So it will show you the information about, okay, DX D012, so whether all of those trees are pressed, or only one of those are pressed, or both of them are pressed. Okay, how many button has been pressed? Okay, how many times the button has been pressed? Okay, and then the CS and DS it show you the last button press. Okay, where is it? Okay, that is the function of 0. So let's say my mouse is over here. Okay, it will record all of this information. So it will store in DX, in D0, D1, D2. Okay, if I press or not pressing the button, okay, all will be. Okay, so that's the function of AX05 with interrupt 33. Okay. Right. So there is actually the program 5 in the textbook. Okay. I don't have it on the slide. Okay, but you can refer it from the book. So basically, you can look that for the AS05 to show you the recorded of the mouse that is last used. Okay, where's the location, whether the button is pressed or not, okay, which button is pressed, and how many times has it been pressed. Okay, so that's related to AS05. Okay, so right, so we've already finished with the chapter. It's a short chapter on the chapter 5. Any questions so far? Okay, so if there is no question, so right, on Thursday will be your test 2, right? So it will be at 4 to 5 p.m. Okay. Do you still have a class after 5? Any of you still have got class after 5?
No, for me.
No.
No.
Okay. Anyone got class after 5?
No.
Okay. Okay, if there's nobody, then okay, we start at 4, then we'll finish at 5, right? So I think if it will be late a little bit because you need to have time to upload the answer. So I don't think it's a problem because you don't have class at 5. Okay, so all right, so we start at 4 and then we finish at 5. Okay, all the best. Okay,
Doctor,
all of you. Yes.
can I know again the coverage of the topic? I mean,
Chapter 2, 3, and 4. Okay, like
two,
the one I already gave you the assignments.
uh, 2, 3, and 4 based on the note, right? Not on the book, right?
Yes, based on the notes. And make sure that, yes, it is chapter, yes, based on the notes. So over here you have chapter 5, right? These notes, right? So
Yeah.
into the chapter 2, chapter 3, and chapter, so it's about chapter 2 is about the unsigned, I think unsigned, sorry, chapter 3 is about arithmetic and logic instruction. Okay, so that's chapter 3. Okay, and chapter 2, it is about the assembly programming. Okay, assembly programming. Okay, and then chapter 4 is
Mm,
chapter 4 is the last one, just before this. Title is integer, yeah, interrupt 21, and interrupt 10, and also the macro. Okay, so that's chapter 4. So basically it is like the one that I assignments for you, all right? So on those chapter 2, so basically it is related to assignment 3, assignment 4, and assignment 5. So assignment 3 is on the sorry, assignment 3 is on chapter 2, assignment 4 is on chapter 4. Sorry, okay, chapter is assignment 3 is on chapter 2, assignment 4 on chapter 3, assignment 5 on chapter 4. Okay, so it's based on that.
okay. And doctor, how about the recording? Can we have it because we need some time to revise it?
It is actually on my YouTube page. Okay, I think the last one that I upload for the last week. Okay, I think I already uploaded the one on the last week lecture. Okay, just check on my YouTube account. Okay, it should be there.
Okay.
But for today, I'm going to upload it soon. Right, I need to check whether I have uploaded the lecture. I think I have already uploaded the lecture on Thursday. Right, so but for last Monday lecture, I already uploaded it there. Okay, so
And
just
any tips, doctor?
the tips is do as much practice as possible, especially on the assignment question that I gave you. Okay,
Okay, doctor.
all right, so that's the tip. Any other question?
No,
Okay, if there's no question, so I'm gonna stop here for today. Right, so we finish chapter 5. Right, so Okay, we will continue the next week on the chapter 6, right? And okay, and the rest of other chapters as well before the final. Okay. Alright, so let's turn on your camera so you can take your attendance for today. Okay, I'm gonna count from 10, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Cheers. Okay, thank you. Okay, have a nice day and then good luck for your test. Okay, Assalamualaikum and bye-bye.
Waalaikumsalam. Thank you, Doctor.
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 You're welcome.